students. Today we are going to start with sulfuric acid. Sulfuric acid is the last part of the study of compounds. I hope you have studied the earlier three parts which I have sent. I have made a video explaining HCl, ammonia and nitric acid. I hope you have gone through all those equations and understanding part. Please write and learn that. Thereafter, we start with the last part, that is sulfuric acid. Now, sulfuric acid is known as the king of chemicals. It is used almost in most of the manufacturing unit. We studied the manufacture of HCl and nitric acid. We studied the use of sulfuric acid in that. Sodium chloride with sulfuric acid, then ammonium nitrate with sulfuric acid. You get HCl and nitric acid. Okay, so likewise, this sulfuric acid has various other uses also. It is used in the manufacture of drugs. It is used in dyes. It is used in explosives. Okay, trinitrotoluene. It is also used in fertilizers, ammonium sulfates. Then of course you must be having inverter at home, most of you. Inside inverter also sulfuric acid is used. Okay, so it is also used for making various chemicals and all. Okay, so now where do you get this sulfuric acid? In nature. In nature we get traces of sulfuric acid wherever there are this volcanoes are there. Okay, or maybe we can get hot springs. At that places we get traces of sulfuric acid. And we also get sulfuric acid wherever there are sulfide beds. Okay, so sulfuric acid is mostly found wherever there are this hot springs and all. In some places in India, Himachal Pradesh, and in those places we get hot spring. So there those has a little trace of sulfur. So it's supposed to heal the people of their skin ailments. That's why it is used in medicinal use. Sulfur has antifungal effect. Okay. Now sulfuric acid, it was initially called oil of vitriol. Okay, it was prepared by distilling green vitriol, that is ferrous sulfate .7H2O. Okay, so it was it was prepared by distilling green vitriol, FeSO4 .7H2O. Now this sulfuric acid is prepared in a large scale by contact process. So I have given a diagram over here of contact process. In this contact process you have to learn all the equations and in short the diagram and how it is manufactured and all. So they can ask you questions on this. Okay, how sulfuric acid is prepared by contact process. So initially sulfur plus pure oxygen is being taken. Okay, why pure oxygen is taken? If you take air or purified air, heat is wasted in overcoming that unreactive nitrogen component in the air. So that nitrogen component, it wastes up the heat energy. So instead of wasting that heat energy, we take direct purified oxygen. So sulfur plus oxygen gives you sulfur dioxide. So it's heated over here. This is heat. Sulfur plus oxygen give you sulfur dioxide. So sulfur burns with oxygen with a bluish flame. Okay, light blue flame it burns. Now after this sulfur dioxide is formed, it is passed through this purification unit. So there are lots of impurities present in sulfur dioxide when it is manufactured from sulfur and air. Okay, so that impurities has to be removed out, especially dust particles and arsenic impurities. Okay, so this dust particle and arsenic impurities are purified in this purification chamber. There is a dusting and scrubbing chamber, and also arsenic purifier is over there. So after it is purified, then it is passed through the testing chamber. You check whether the sulfur dioxide prepared is pure. If it doesn't have impurities, well and good, it is sent to the catalytic chamber. But then if it has impurities, then again it goes back to square one, the purification unit. Okay, the reason behind it is the sulfur dioxide if it has impurities, then it may affect the catalyst. It may stop the catalyst from working. It will render it ineffective. So the catalyst has to be in the pure state, otherwise we will not get sulfur trioxide. Now here oxygen is used in great quantity, because then only sulfur turns into sulfur dioxide and sulfur dioxide turns into sulfur trioxide. Okay, so now this sulfur dioxide is taken into this catalytic chamber. The catalyst used over here is vanadium pentoxide in shredded form, and there is a promoter also, potassium oxide. So what is the catalyst used over here? Vanadium pentoxide, and the promoter is potassium oxide. So promoter, you know what is promoter? It helps the catalyst, and catalyst, it speeds up the reaction without itself taking part in the reaction. So here when it is passed through this vanadium pentoxide, why vanadium pentoxide is used? Because it is cheap, and unlike other catalysts, it does not get poisoned easily. Alright, then after that the sulfur dioxide, when it is produced, it is passed through this concentrated sulfuric acid. Concentrated sulfuric acid is sprinkled on top. Then sulfuric acid reacts with sulfur dioxide to form pyrosulfuric acid, H2S2O7, pyrosulfuric acid or oleum. Okay, so and then when it is added to requisite amount of water, we get sulfuric acid. Now this sulfur dioxide, directly we can add water and we can get sulfuric acid, but then this sulfur dioxide is highly soluble in water. It forms dense white fog which are difficult to condense. So the whole lab or the whole factory where this is manufactured becomes foggy and you can't see anyone over there. So in order to avoid all that, we add a little quantity of concentrated sulfuric acid, so that sulfur trioxide reacts with sulfuric acid and form oleum, H2S2O7, and that oleum, when it is added to requisite quantity of water, you get sulfuric acid. So this is the method how sulfuric acid is manufactured in a large scale. So the reactions are given over here. You have to write and learn them by heart it. So sulfur plus oxygen gives you sulfur dioxide, iron sulfide. Now see, this iron pyrites can also be used. Instead of taking sulfur, iron pyrites can also be used. This is also one of the method. So learn both the equations. Sometimes they ask you from iron pyrites. So if it's from iron pyrites, it is FeS2 plus 11O2 gives you Fe2O3 plus SO2. Now this SO2 which is formed is passed through this catalytic chamber, vanadium pentoxide, 450 to 500, 1 to 2 atmosphere pressure gives you sulfur trioxide plus heat. And once sulfur trioxide is formed, then you add sulfuric acid, concentrated sulfuric acid, and you get oleum, H2S2O7 or pyrosulfuric acid. And remember the catalyst, temperature and pressure. Okay, then this oleum plus water gives you sulfuric acid. So this is the whole process. Please go through it, learn the equations, and we'll go further with the properties of sulfuric acid. Now sulfuric acid is a very oily dense liquid. Okay, it has a very high density, and it has a boiling point of 338 degrees Celsius. So over here, when you get sulfuric acid with water, so you may think that when you boil it at 100 degrees Celsius, all the water will evaporate and sulfuric acid will get back at 338 degrees. But then nothing like that happens. Both water and sulfuric acid, they evaporate at 338 degrees Celsius because they have formed the constant boiling mixture. I guess you must have studied constant boiling mixture in HCl and nitric acid. So both the mixtures, they evaporate at 338 degrees Celsius, since the boiling point of sulfuric acid is 338 degrees Celsius. Now this sulfuric acid, when you want dilute sulfuric acid, okay, this is concentrated sulfuric acid which you have. So if you want dilute sulfuric acid, you have to add sulfuric acid over water, not water over sulfuric acid. See, here you have a vessel. In that you have H2SO4. So if you add water to make dilute sulfuric acid, so then what happens, you know, the water is less dense. It gets collected on top and it gets spurt. Spurt means what, you know, like for example, when there is hot oil and when you put little bit sprinkle water, how it spurts, like that this water will spurt, and so it can come on person's face also. So in order to avoid that, they take this water over here and they add sulfuric acid on top. So this method they don't employ to get dilute sulfuric acid. They add sulfuric acid on top. Now sulfuric acid is dense, it gets collected down over here, and the heat produced is absorbed by the water. Unlike over here, the heat produced just comes on our face, it spurts. So that's how this method is employed. When you want dilute sulfuric acid, you add sulfuric acid over water, not water over sulfuric acid. Now another thing about sulfuric acid, it has properties of acid. It dissolves in water, it forms dibasic acid, and it is a very hygroscopic liquid. So that means it absorbs the moisture. That's why it is kept in glass bottles, closely tight glass bottles. Okay, and then about sulfuric acid, there are many properties of sulfuric acid. It is sour to taste, properties of an acid, and further, of course, the reactions of sulfuric acid, that it is a very reactive acid, and it is a strong oxidizing agent. So and it is a drying agent. Sulfuric acid is a strong drying agent, and it is a dehydrating agent. So you have to learn all those equations on that also. Equations of sulfuric acid. The first earlier one, the 4 equations which we learned were the manufacture of sulfuric acid by contact process. So here we have sulfur plus oxygen gives you sulfur dioxide. We can also use iron pyrites, FeS2 plus 11 oxygen gives you 2 Fe2O3 plus 8 SO2. This is important equation. Then the next one is sulfur dioxide plus oxygen in presence of vanadium pentoxide, 450 to 500 degrees Celsius, 1 to 2 atmosphere. We get sulfur trioxide plus heat. It's an exothermic process, so heat is evolved. So remember the catalyst, vanadium pentoxide, temperature 450 to 500 degrees Celsius, 1 to 2 atmosphere, and promoter is potassium oxide. Then sulfur dioxide plus concentrated sulfuric acid gives you pyrosulfuric acid, H2S2O7 or oleum. Now this H2S2O7 plus water gives you sulfuric acid. Now equations based on the properties of sulfuric acid. Sulfuric acid, acidic property. So dilute sulfuric acid acts as an acid. So the properties of sulfuric acid as an acid. So zinc plus sulfuric acid gives you zinc sulfate plus hydrogen. Now you must know how to identify hydrogen gas. It burns in the air with a pop sound. Then same way, iron plus dilute sulfuric acid gives you iron sulfate plus hydrogen. Sodium sulfate, these are all the bases, and these are all the metals, active metals. Sodium oxide plus sulfuric acid gives you sodium sulfate plus water. Then magnesium oxide plus sulfuric acid gives you magnesium sulfate plus water. Then zinc oxide plus sulfuric acid gives you zinc sulfate plus water. Then copper oxide plus dilute sulfuric acid gives you copper sulfate plus water. Sodium hydroxide plus dilute sulfuric acid gives you sodium sulfate plus water. Then zinc hydroxide plus sulfuric acid gives you zinc sulfate plus water. Now with carbohydrates, sodium carbonate with dilute sulfuric acid gives you sodium sulfate plus water plus carbon dioxide. Then copper carbonate plus water plus sulfuric acid, dilute sulfuric acid gives you copper sulfate plus water plus carbon dioxide. Then potassium bicarbonate with dilute sulfuric acid gives you potassium sulfate plus water plus carbon dioxide. Learn to balance it also and write it down. Okay, and ask someone to take it up for you. Sodium sulfide with sulfuric acid gives you sodium sulfate plus water plus sulfur dioxide. Then sodium bisulfite with sulfuric acid gives you sodium sulfate plus water plus sulfur dioxide. With sulfide, sodium sulfite plus sulfuric acid gives you sodium sulfate plus H2S gas. H2S gas has a rotten egg smell. Then zinc sulfide plus sulfuric acid gives you zinc sulfate plus H2S gas. Iron sulfide plus sulfuric acid dilute gives you iron sulfate plus H2S gas. Now sulfuric acid as a diabasic acid. Now sulfuric acid reacts with sodium hydroxide to give you an acid salt as well as normal salt. Now see, sodium hydroxide insufficient, when you react it with sulfuric acid gives you sodium bisulfate with water. Now this is an acid salt. Then sodium hydroxide with sulfuric acid with normal salt, sodium sulfate plus water molecules. Then as a least or non-volatile acid, sulfuric acid acting as a least or non-volatile. This we have studied earlier in the manufacture of HCl as well as nitric acid. Sodium chloride with concentrated sulfuric acid, temperature less than 200 degrees Celsius gives you sodium bisulfate with hydrochloric acid. Potassium chloride with concentrated sulfuric acid, temperature less than 200 degrees Celsius gives you potassium bisulfate with hydrochloric acid. Sodium nitrate with sulfuric acid concentrated gives you sodium bisulfate with nitric acid, temperature less than 200 degrees Celsius. Potassium nitrate with concentrated sulfuric acid, temperature less than 200 degrees Celsius gives you potassium bisulfate with nitric acid. Now sulfuric acid as an oxidizing agent. Now carbon reacts with this is a non-metal. Carbon reacts with concentrated sulfuric acid to gives you carbon dioxide plus water plus sulfur dioxide. Then sulfur plus concentrated sulfuric acid gives you sulfur dioxide plus water. Now hydrogen iodide with concentrated sulfuric acid gives you iodine plus water plus sulfur dioxide. Now H2S gas with concentrated sulfuric acid gives you sulfur plus water plus sulfur dioxide. Now sulfuric acid as a dehydrating agent. So this is glucose, okay, or sugar. So sugar with concentrated sulfuric acid gives you sugar charcoal with water. Now this sugar charcoal, it is black spongy mass of carbon formed. Steam is seen to be evolved whenever sugar is added to concentrated sulfuric acid. Then copper sulfate 5 water molecules. So this is blue hydrous copper sulfate plus water molecules. When concentrated sulfuric acid is added, you get white anhydrous copper sulfate plus water. That means the water is removed out. It is dehydrated and the color changes from blue to white. Okay. Then the next thing is the test of sulfuric acid. Now there are two tests. One is for concentrated sulfuric acid, one is for dilute sulfuric acid. So test for sulfuric acid, copper with concentrated sulfuric acid gives you copper sulfate plus water plus sulfur dioxide, okay, gaseous. And how do you identify this sulfur dioxide? Turns potassium permanganate from pink to colorless and turns acidified potassium dichromate solution from orange to clear green. Remember this. Okay, another test is which you already studied in the manufacture of HCl. Sodium chloride with concentrated sulfuric acid, temperature less than 200 degrees Celsius give you sodium bisulfate with hydrochloric acid gas. And how do you identify hydrochloric acid? A glass rod dipped in ammonia, when it's brought next to the fume of HCl, dense white fumes are formed. Now test with dilute sulfuric acid. Now barium chloride or lead nitrate, when it is react with dilute sulfuric acid, we get barium sulfate or lead sulfate, which is a white precipitate. So this also equation you learn. Test for dilute sulfuric acid, barium chloride or lead nitrate, when it is treated with dilute sulfuric acid, we get barium sulfate or lead nitrate, which is a white precipitate. Alright. So that's all we have in this lesson, sulfuric acid. I hope you go through the video nicely and learn the equations, write them down. When you see the description box, there is a link given which has a PDF which has all the important questions, previous year's question, and of course with the solutions. Please go through that. And if you like this video, please do not forget to like, share and subscribe this video for more videos of this kind. Till then, bye bye, see you.